Hi everyone, welcome back to C Sharp Corner Live Show. I'm your host Stephen Simon, and we are back with another episode of C Sharp Corner MVP Show. And this episode of this show is going to be really interesting, and I have very exciting guest joining us today. He's one of our very own, and he has been to many of our offline events, conferences. Now he has been speaking in our virtual events. He is. Not only C Sharp on the MVP, he's also the chief community advisor for our community. And not just that, he has been a Microsoft MVP. And not just that, he has also been a regional director. And I like to call him Mr. Ari. And to some people, also Santa Claus. So let's go ahead and invite our guest of the show today, Alan O'Neill. Hi, Alan.
Hello,
Welcome to the live show.
it's me, Santa Claus, aka Alan, aka C Sharp Corner MVP, aka Gangster, wearing my gangster hat. Yeah,
You look cool in that outfit.
yeah. Well, this is actually I was asked what I wanted for a. Is it straight? Yeah. You're on a TV and you have your tie, and it's like you think you're adjusting it, and you do it in the wrong direction. So,
Mhm.
yeah. So I was asked what I wanted for Christmas this year.
Mhm.
A present from my better half, and I decided I want this cap because it's the cap with the emblem of the Morgan Car Company. So,
Okay.
yeah, it's kind of cool. So the if I can get it up there and you can
Yeah.
see it, yeah.
There you
So
go.
more, yeah. Okay, so I'll bring it up there a bit closer, and we can see
Focus,
it.
focus gone.
There we go. Hold on. There we go.
Yeah.
Right. So it's the Morgan Car Company. I aspire one day to owning one of their cars, um, and because the cloud is going to bring us all this magic. Okay, so that's why I had that on, because it's so cool, and I can go and I can spend time driving my fancy Morgan car.
Hmm.
They're built by hand in the UK, so they're very awesome. And the reason I'm wearing my glasses, right? It's not because I'm blind or there's too much sunshine. It's because the future is so bright with clouds that I've got to wear my shades. So.
Oh my goodness. Alan, it's said that people who can crack jokes or bring smiles to other face, right? They are very very unique people in the world, and they're very less. And you are one of them, and definitely you are very unique. Every time you come, you have that energy, right? You bring that positivity with you. It may be offline event, it may be in these online events, but it is always so exciting to host you. And yeah, definitely the future of cloud is really bright. But before even we go ahead and start talking about, Alan, the future of cloud, let's take a step back and try to understand at the very first place that what is this cloud. And it will be pretty interesting also to know on how did uh, your journey started with this cloud computing.
Sure. So, really, the when someone says to me, what is the cloud, right? The simplest answer is it's somebody else's computer, and that's true, right?
Yeah.
Because this cloud thing. I got a book, also from my very better half, thankfully to her, many years ago, and it was called "The Plumbing of the Internet" or "Internet Pipes," and it was all about the big, thick, fat cables that went under the sea
Mhm.
that brought the internet from the US to Europe and Europe to Asia and Asia to the rest of the world and everything else. Um, and it was like this hidden thing that nobody ever knew existed. And there's special submarines that go and they lay these cables down and they measure them and make sure they're in good condition and fix them when they go wrong, etc., etc. And recently, of course, it's become quite a national security issue for most nations in the world, to ensure that these big thick pipes that go into the sea that connect one
Mhm.
country to the next are protected from terrorist attacks and all sorts of things, because um, it is the plumbing of the internet, right? So we say the
Mhm.
internet, and it consists of so many different parts. We've got the cloud. Well, the cloud is other people's computers. So it is collections of computers that are put together on racks, and these racks are put inside containers, and containers are stacked one on top of the other. And I'm not talking about Docker or Kubernetes
Yeah.
containers. I'm talking about physical shipping containers,
Mhm.
and uh, if you go and look up some of the amazing stuff that's being done with some of the data centers at the moment, Microsoft, for example, Sean, absolutely, they're huge,
Yeah,
huge cables, right? Huge.
I think not
Um,
many people know about it. I think that not many people know about
yeah,
this.
yeah.
Yeah.
In fact, maybe you know what we should do for the fun of it, Simon. We should actually do a show on the physical infrastructure of the internet, right? I'd love to do that show, and I'll tell you exactly how everything gets connected together and all of the
Mhm.
magic that's underneath there, right? But here's the thing: so we have these a computer. And the computer is stacked into a rack, and we know this. We can visualize this in our head, and then they're connected through um, networks
Mhm.
within the racks, and then each rack is connected to another rack, and then all of the racks are connected inside a container, and then the
Mhm.
containers are stacked literally physically, big, huge shipping containers on top of each other, and then those are contained inside a huge, big building, which is called a data center. And
Yeah.
then there's these big, massive pipes containing billions and billions of fiber optic cables that come out of those data centers, and they then get connected under the sea to guess what? Other data centers, right? So when you go in and you go to open up a website or to look at YouTube or to go to Bing
Mhm.
and do a search or whatever it happens to be, the data that's coming to you, like that's on somebody else's computer. It's coming from a server that could be the other side of the world,
Mhm.
or it could be data that originated on the other side of the world and then is replicated to a server, let's say in Delhi, close to you, or maybe in
Mhm.
my case, I'm only about 40 or 50 miles, kilometers up the road from me, is actually the Microsoft data center for Europe, Europe West. Is it Europe North? North Europe. Um, so all of Europe is fed from a big data center just a few miles up the road from me, which is kind of cool, right? So
Yeah.
what is the cloud, and why did it come to be what it is? At the end of the day, what the cloud allows us to do is it allows us to only worry about code and our delivery of services, and not to have to worry about managing the computers and the infrastructure that are required to serve all this stuff out. So
Yeah.
when we go and we pay Azure our few dollars a month for our systems, or AWS or Google or whatever, we're paying them literally to rent their computer space, right?
Yeah.
So and all of the amazing services that they've built around this. So what is the cloud? The cloud is somebody else's computer. It's services running on somebody else's computer that allows us to connect together all of the information and the services that we've built as a technical community of engineers and IT pros and everything else over the past couple of years. So,
Yeah.
yeah.
Yeah, so that very nicely explains, Aaron, about the what this cloud computing is, starting from their devices connected to each other. At the end of the day, everything is connected, right? You have kind of computers that are stacked upon each other. But where does the this cloud term fits? Because I don't see you ever mentioned like the cloud thing, right? It's at the end of the day, you're talking about pipes going under the sea. You're talking about continents connected to each other, but I don't see the concept of cloud. How does that fit?
So, uh, politicians, right? Um, you either love them or you hate them. I mostly hate them. I think
Hmm.
most people mostly hate them.
Yeah.
The great Irish author and scholar George Bernard Shaw said that politics is the last bastion, the last place for a scoundrel to go. So if you ever look at a politician, you know that it's the last place for them to run. Is they've tried everything else and they fail, so they say, "I'm going to be a politician, a gangster in public."
Yeah.
So there was a politician in the west of Ireland who, like most politicians, didn't know what he was talking about.
Hmm.
And he heard some word, some buzzword, and he decided that he knew what this was. So he decided to go and talk publicly about this. And he said he raised a point in a local government committee meeting, which was picked up by local media and then by national media and then by the world media. And it was like he was made look like a fool the world over. He said, on the west coast of Ireland, we have very turbulent weather, and we have a lot of clouds. So we should get a lot of investment into the west of Ireland's for this cloud computing because we have a lot of clouds. Okay, um, and
I cannot
this,
believe that's true, Alan.
it is actually true. It is actually true. If you go there and you go into your Bing or to your Google and you type in Ireland politician, West of Ireland cloud computing, I guarantee you, go there now and do it, right? I guarantee you will find this reference, right? He's an idiot. So in any case, what is cloud computing? Why is it even called cloud computing? Because it's a thing that we don't even have to touch, right? When I'm sitting here now, the last time we talked, I would have had a set of these on me, right? Look,
Yep.
right, a set of headphones. I don't have those now. I have these little up things in here now, right?
Which are not working best
So
now. Yeah.
uh, they're not working good.
Not the best, but it's okay. Let's continue.
Okay, all right. So in any case, uh, uh, so my voice and my audio is transferring just in the air, let's say, right, by Bluetooth. Well, what is Bluetooth? Bluetooth is just wireless, or it's a form of wireless. Um, so I'm in the house, and if I do this, right, my hand is moving through radio waves. Yeah.
Mhm.
So does that mean that actually, when I say where is the internet? Well, the internet is everywhere, right? It literally is. So, do you have internet here? Hold on. Oh yes, I feel it. We have internet, right? So in actual fact, when we say cloud computing, we mean that our data, our information, our services, they're up there. The cloud isn't something that you can go and touch. A physical cloud isn't something you can go and touch. It's ethereal. If you went up in an airplane and you reached out and you went to touch one of these fluffy clouds that looks like uh, a candy floss that a kid
Candy,
eats, right? It's not like that. It's not like cheese on the moon. Okay, it's this ethereal thing. It's just a gas that moves out of the way when you touch it. And
yeah. Mhm.
information and data is exactly the same thing. So when we say cloud, we use the word cloud. That's what we mean. We mean it's this nebulous thing that's up there that we can see it from afar, but when we get up there, we can't really touch it. Right? Okay. So in other words, it's a representation of a collection of services and data and information that are available to us to pull down whenever we want, but they're
Mhm.
not necessarily here and managed by us. There was a great song out years ago by a singer called Kate Bush, and it was called Cloud Busting. And the video for this song showed her running up this hill, and that's part of the song is running up the hill.
Mhm.
And they were kind of shooting these guns at clouds and everything else. But of course, the clouds weren't going away; they were just there. And it's the same concept: is that
Yeah.
it's nothing more than a word that lets us know that there's this ethereal thing that we can see, we can imagine that stuff is up there, but we can't actually touch it. In the same way as if I went up in my car, which I couldn't do because we have local restrictions on driving and travel. But if I could get in my car and go to the Microsoft uh, cloud center, they wouldn't let me in.
Yeah, I was gonna ask. I was gonna ask, would you let go there?
No, it's high security. I wouldn't be allowed in. So
Mhm.
I can sort of see my stuff, but I can't touch my stuff. So that's why it's called the cloud. It's because it's something that is there. It's available. You can see it, but you can't necessarily touch it. But you can go and you can have rough weather. You can knock your house down with a hurricane. You can take your laptop and you can smash it up. But guess what? The cloud will always be there, right? Your data will always be up there in this nebulous place that you can just pull it down.
Yeah, so that's good idea to understand the concept of cloud word behind this cloud computing. And given the fact that, Alan, cloud computing gives you the benefit of accessibility, scalability, and flexibility on the fly. Do you, this might be a tricky question. Do you think we have gone back doing the same thing of we had some warehouses earlier, right? We had our on-site, then we had some warehouses, but we have kind of gone back same, but given these resources to more powerful vendors like Microsoft, Google, and IBM, and we are doing the same thing. Did you ever feel so?
Do you mean like, do we feel like we're going backwards?
Yeah, I mean, at the end of the day, we are doing the same thing. It's just that we have given our data to some big vendors. I mean, yes, they bring some good capabilities of AI, machine learning, better devices, better hard disk. But isn't it that we are getting more dependent on these vendors? Did you ever feel
Yes,
so?
yes, we are, and that's quite interesting.
Hmm.
Um, and it also feeds very much into the topic of actually today's show, which is the future of cloud, right? While every vendor would love you to go in and to write your application or your system so that it only uses their dedicated proprietary services, right?
Hmm.
Um, in actual fact, more and more companies are using the technology of containers and
Hmm.
Kubernetes to write their systems in a way that is what we would call cloud vendor agnostic. And this means that we can take the code that we write, and we can say this goes into this package or this box over here, um, and we now deploy it onto AWS, and it'll run. And if we decide we want to change vendor in the morning, well, then we can just press a few buttons, and guess what? It'll deploy over here into Google or down here into AWS or into Azure, so that by leveraging the newest technologies, like, for example, containerization, we can make sure that our services are portable from
Hmm.
vendor to vendor. And actually, it's interesting because on one hand, you can say, well, doesn't it make us more dependent on these people? It does, but it also makes us actually much more independent, because it also means that because of the way that we can now um, uh, build our systems and the way we can distribute these systems across different vendors, it means that we can also lower the risk for the business. So
Hmm.
we're not saying all of our eggs are in that basket. I saw a really cool tweet about 5 or 6 weeks ago. Do you remember there one day for a couple of hours Google was down? Like
Yeah, yeah.
there
Very
was big,
recently, I think so. Yeah.
yeah, huge big outage, and this guy sent a tweet and he said, my central heating wouldn't work, my aircon wouldn't work, the lights wouldn't come on in my house.
Hmm.
I am now reevaluating why I have Google IoT Nest controlling my entire system in my house. And it was right, because basically some glitch happened. Google's infrastructure went down, and everybody who were locked into one vendor
Hmm.
were like, got in serious trouble, right?
Yeah.
However, if you had set up your system and distributed it across multiple vendors, you wouldn't have experienced that problem, or at the very least, you'd have reduced your risk dramatically of being affected by that problem. So,
Hmm.
while on one hand you can say absolutely, it seems like a bad thing that we're reduced down to all these vendors, it's also a good thing, because it creates more competition in the marketplace.
Hmm.
Um, and I think that if we as engineers and architects and technologists do our job correctly, we'll make sure that we do balance that load, and we're not dropping everything into one place, and we're reducing that risk. So I think it's probably a good thing.
Yeah, more leans to a good thing. Yeah, yeah.
Yeah.
Yeah, yeah. So Alan, we have seen in past 10 months, I mean, almost like entire 2020, we have seen that infrastructure, IT infrastructure played a very vital role, because we all have gone virtual. We have started doing our meetings virtual, and three cloud service provider, that is AWS, Azure, and Google Cloud, they have always emerged as the best. So do you think going forward, since we have gone so much of virtual, that creates an opportunity to go ahead and reshuffle these top three players? Will that make sense going forward in the coming years?
So I think that we will probably remain with a number of core vendors. Um,
Hmm.
One of the problems, um, and we've seen it with Google and Facebook, and Microsoft and others over the years, is that whenever somebody emerges that's a challenger to one of these
Hmm.
people, um, they usually do one of two things. They say either A, how can we destroy it? Or number two, let's buy it and then close it down so that it's no longer competition. And
Hmm.
Facebook actually um, are now entering into very severe litigation in the US, antitrust laws, because of this type of thing. And it's one of the things they fear the most is that they'd be broken up because of the way that they act. Um, and I think that now that we see a new administration coming in the States,
Mhm.
um, there's probably uh, less of a danger of this happening, at least for the next sort of 6 or 7 years, depending on how the administration lasts. Because let's face it, at the end of the day, the direction of the internet outside China, right? Because that's different. But the direction of the internet in the rest of the world is very heavily dependent on what happens politically in the States. So
Mhm.
I believe that um, uh, yes, we have 3 or 4 incredibly strong vendors. We have other ones that we don't necessarily talk about or hear about. Uh, OVH in Europe is one big one. There's a number of other very big private uh, digital warehouse, data warehouse people that do very specific things, like they focus on media transmission, etc. Um, uh, and you don't generally hear about these too much because they don't upset the apple cart. But when they start to upset the apple cart, well, then you see them getting bought over. So um, it's an interesting time. I would hope that with the new regime that we have in the States, that it would at least stabilize some of this for the coming years.
Yeah, definitely. I think apart from what you said, I don't know. I think you must have heard about Alibaba too. Like these are the other companies that are just coming into, right. They've started expanding. And so when we talk about the future of cloud computing, Alan, we cannot ignore the other technologies that are people are really focusing on that. The first one is AI, and the second one is serverless. We're going to talk about serverless later on, but let's focus on the AI. So now AI projects have this dynamic change in code, models, data, and they all needs to be improved. And for that, we need a good infrastructure. If we don't have a good infrastructure, we will not be able to go beyond proof of concepts or just prototype, right? So how do you see cloud computing giving a platform to AI to move to go ahead and become a reality?
Mm. So, 2 things. I always say this, and I will keep on repeating it because it's important, right?
Mhm.
Um, what's the difference between AI and machine learning? AI is written in PowerPoint. Machine learning is written in Python. Okay, so that's that's the first thing. Um, in other words, let's not get confused. The robots are not going to take over the world in the morning, so we don't have to worry about that, right?
Yeah.
This is about machine learning. Machine learning has a slightly different approach to getting the job done than standard programming, historical programming. Historical programming is imperative in that we say, we want you to go and do this, 1, 2, 3, 4, and it goes and carries out those steps and it produces the end point. Whereas with machine learning, we say, here's the data, how it looks like now, and here's the data, how it looks like when the job is finished. Figure out how to transfer between those two. Okay,
Yeah.
figure out how to get from one point to the other. And there's all sorts of fancy machine learning algorithms that go and do this stuff. But that's what they are. They're just algorithms, right? And what's an algorithm? An algorithm is nothing more than if then else. Never forget that. Okay, it is nothing more than if then else. And sure, you've got neural networks that are. Guess what a neural network is? It's a combination of if then else. That's all
Yeah.
it is, right? So
Yeah.
so long as we keep that in the top of our head, it's nothing to be afraid of. Now, how can we go and use these things to help us get to the next level? Well, for example, if we think about different areas that machine learning is being put into play, one of them is in the cloud, whereby we're saying, how can we allow machine learning to help us in the cloud? How can we allow it to help our services be smarter? Well, how about if we put some machine learning together, a bit of an algorithm, and what it would do is it would monitor, let's say, the incoming IPs for people who are connecting into the C Sharp corner website, and it would monitor maybe the frequency of them coming in. It would monitor the geolocation of those IPs. And if it noticed a particular pattern, it might say, hold on, those requests coming in from those IPs look like they're coming from Europe, but Europe is actually asleep at the moment, right? Because we're 6 hours ahead or whatever, and it's only 9 a.m. in the morning. So it actually looks like that's probably a denial of service attack, right? So we can go and we can go and do whatever action we take to help mitigate a denial of service attack. We might say, oh, again, we're have a queue system, let's say, right? And this is a classic example of where AI is, or machine learning is being used right now in the
Mhm.
cloud to help us do things better and smarter. So it's typical that if we have a lot of work to do, we have this work put into jobs, and those jobs are in a queue system. So we have a big queue system, and we have these workers that basically drink from this queue, this pool, and they go to do the work, and then they move it on to the next section, etc., etc. But how do we know when the backlog of all of this work is starting to actually get too much, and there's going to be a pressure point, right? Well, what we can do is we can use a technique, or technology rather, called KEDA, K-E-D-A, and it's a Microsoft technology that uses some ML at its core. And what it does is it will monitor a pool or a queue, a pipeline of work,
Mhm.
and using various metrics, it will be able to predict if that pipeline is about to grow exponentially. If there's sufficient workers to drink from the pool and make sure you keep your SLAs, etc.
Mhm.
And that's one example of, and what happens then is it gets connected then via an API to your workers, so that your uh, um, system can ensure that it meets an SLAs. It's SLAs, it's service level agreement. Because the last thing you want is for a customer to ring you and say, hey, I was meant to have my data delivered at 9 a.m. this morning, and it's already 10 a.m. and it looks like you're not going to deliver until 10 p.m. tonight. Why is that? Oh, because we've got too much work in our system and we haven't deployed enough workers, and a programmer's got to go out and he's got to go and redo something really fast on the AWS or the Azure dashboard or whatever to spin up another 10 servers. And no, you can
Mhm.
build in very simple machine learning using cloud native tools to monitor these types of workloads and to make decisions for you, and to say, if the backlog looks like it's hitting a certain threshold, spin up these machines. Okay. And this is how things like you mentioned there just a few minutes ago, serverless, right? This is the type of technology that is at the core of how serverless works.
Mhm.
To know when can we take something and put it to sleep? How do we know when it's likely that that particular job is going to need compute resources? How do we
Mhm.
know when it's going to explode? What time of the day? Because of certain services, for example, um, uh, I can tell you, and it's probably the same in Delhi as it is here in Dublin, that at 6 p.m. there's always an electricity spike. Okay,
Yeah.
so why is that? It's because everyone sits down to make a cup of tea, right?
Yeah.
So everybody turns on the electric kettle, right? So there's a power surge, and the power stations have to plan for this, right?
Mhm.
And they use machine learning algorithms the same as everybody else. And um, uh, I mean, you'll find it funny, but it's true.
Mhm.
One of the things that I know that the standard machine learning algorithms for power plants do,
Mhm.
that they take into account, they don't just take into account things like you know, time of day, right? 6 p.m. Everybody's coming home. They're
Mhm.
going to make a cup of tea, right? They even do things like they monitor TV listings.
Oh,
Why?
really?
Yeah, true story, right? Power operators monitor TV listings. They do it algorithmically, right?
Yeah.
But what they do is they say, well, watch a particular show. And if we see a particular show gaining traction, well, then we need to be sure
Yeah.
that we plan for the time that it's going to be coming on, because more
Yeah.
people are going to be sitting down, turning on their TVs, and therefore more power is going to be consumed.
Must have happened with Game of Thrones.
Oh yeah, oh yeah, oh yeah. You know, and this is where having machine learning natively embedded into the very core of operations in the cloud helps us to scale these things. Because if we didn't have machine learning, can you imagine the volume of people we would need to work these things out? Like, who would think, oh, I need to go and look at the TV listings to monitor if a particular TV show is taking off so I can plan the power consumption for the country, for the entire nation, right?
Yeah.
2 months ahead and 2 years ahead, etc., etc. That's what they do. The same thing with we might look at the uh, let's say an election, right? And we say, well, there's going to be an election count. Well, what generally happens immediately around the counting time of the election? Well, we see a lot of people sending messages, right? So depending on the outcome of the election, we might see more people sending messages or less people sending messages. So who needs to know about this type of thing? Well, people like telecommunications providers,
Yeah.
so that they can ensure that they have enough systems up and running to take the capacity of all of these messages flowing through. Excuse me, it's not COVID. Um, in addition, the data centers, right? The data centers also use this type of thing to be able to monitor power consumption, because if they notice that, let's say, for example, we have some event, I don't know, in the UK, maybe they have the Queen's speech, right? So
Okay,
millions
that's
of people
important.
tune in for the Queen's speech. Well, they're going to see an upsurge. Will you see an upsurge in TV watching? Yeah, but actually, you'll see an upsurge in people watching video on their phone as well. So, it affects everybody. So, having machine learning right in at the core of your operations allows you to help predict what's going to happen in your system, and allows you to react to it in an intelligent way. So, um, uh, in the recent past, we've seen machine learning used very heavily, of course, in the management of data centers and um, cloud services themselves. But
Hmm.
now what we're seeing more and more is we're now seeing um, uh, organizations and companies saying to themselves, how can we use this machine learning now within our applications? How can we use this to help us do small things that will have big benefits for our customers, to save us time, save us money, lower risk, improve margins, etc., etc., etc. So
Yeah,
I'm
and
going to, I'm going to drink some water when you ask the next question.
yeah. So when you say that now organizations are looking to go ahead and add AI capabilities into their existing application, one of the benefit that also quite cloud provides is the cognitive services on the fly. You need not be a data scientist. You can go ahead, create an API, create an endpoint, and just go ahead and start leveraging it. It may be a computer vision, it may be natural language processing, it may be speech to text. It can be anything. So maybe that is where also cloud really helps. Now, Alan, when cloud provides so much of opportunities, it takes so much of labor from the people don't have to work so much. So, do you think this kind of replaces or displaces the jobs, especially talking about the IT pros? Because if I talk with respect to database architectures, the more we move towards PaaS, right, their role decreases because we're now more dependent upon the Azure. So do you think this is kind of affecting people's job?
Um, Clearly it does, right?
Mhm.
How's my voice, by the way? Because I've changed my mic while
That's
you're.
much better, to be honest.
I still have the voice coming into my ear, but I have the mic coming out through my other mic. So
Yeah.
interesting. Technology, whoa! It's great that it works. So here's the thing. Uh, Years ago, um, we had offices where we needed an IT pro to come in and to set up our machine and to um, make sure it was patched and up to date and da da da. We still have that, right? We still have those folk who deal with the physical machines. Um, but it's interesting because a lot of those folks now have moved beyond the simple act of maintaining the local machines. And they're now moving more into the ops side of the DevOps thing, right? You also hear about things called SRE, which is Site Reliability Engineer. That crosses over between a kind of a developer and an IT pro type person who knows a lot about the infrastructure side of things, but also knows about the development side of things. And you have then, for example, your DBAs, right, your database administrators, who aren't developers, but yet they still have to take care of the data. And whereas previously they might have gone into a room where there was all sorts of servers and they had their in-house blinky box room. Now instead they do it at the dashboard, and the dashboard talks to somebody else's computer, which is the cloud. Right?
Yeah.
So I think that what we have is not so much as a replacement of jobs, but a shifting of focus for those jobs. So I think that somebody who, let's say, up to 5 years ago, their job was running around in a building and making sure things were connected, and making sure that the 20 or 30 servers that they had in the back room were running, and checking them for disk failures and all that kind of stuff. They're still doing a lot of the same thing, but now it's on remote machines. Okay, because despite the fact that we have this wonderful thing called the cloud, we still have a huge volume, a tremendous volume of existing code and applications that don't run on the cloud, right?
Yeah.
Can't run on the cloud, right? So, those are always going to be there. Now, another thing that we have is we have those particular systems, and people have done what's called lift and shift to move those up into the cloud. But despite the fact that they're on the cloud, they still need to be managed because they're just being put up there into virtual servers. So instead of having one physical box over here that has, 40, 50 Windows services running on it with a DB and whatever, and it's only, let's say, fully utilizing maybe 40, 50% of its actual capacity, now sitting as a virtual box on top of a much bigger machine, and it's much more efficient, and therefore the total cost of ownership for the company is lower, et cetera, et cetera, et cetera. But the bottom line is that the service inside it still needs to be managed, and that service is still managed by the IT pro. So yes, there is a shifting in the type of work that is being done. I don't believe there is displacement. In actual fact, it has been shown time and time again that the cloud as a thing, right, or as an industry or whatever, the cloud has generated more jobs than it has displaced. And that will continue to be the case. And again, it's the same with, as AI comes in, it will generate more jobs than it displaced. That's absolutely guaranteed. And the jobs that it will generate will be either ones that simply cannot be done by machine learning or an AI, or ones that humans are simply better at inherently. Like how many people 50 years ago were employed in the industry surrounding and related to, let's say, horses and transport, right? Even 50 years ago, we were still using horse-drawn carriages on the street, right? Now it would be quite unusual to see a horse-drawn carriage.
You know better.
I mean, I actually saw some yesterday when I was out driving my car, and I was stuck behind the buggers, and I was giving out, going, "Get off the road!" But if you think about that particular thing, I mean, you had the horse. Well, you had somebody who had to stable. You got a stable hand. You have somebody who's going to make the horse shoes. You've got the person who made the carriage. You got the carriage maker. You've got the wheelwright who made, because there's a particular skill in making wheels, and that gets in somebody who knows how to do spindling and everything else, and it's the wood makers and and then of course there's the feed that has to be brought for the horse and everything else. So are those jobs gone now? Yeah, they are, but they're displaced by something else. So while those trades and those crafts may fade away, it doesn't mean that that's work that's gone forever. It's just displaced to something else. In the same way as when we had to go off years ago and put together a database. Well, as an engineer, you had to know a lot about databases and tuning and your code and all these different things. You don't really have to know that now, right? You can just go in and just say, well, JSON, put it into Mongo. I don't care, right?
Yeah.
And you don't have to worry about relational stuff and in most cases. So, like, are we out of a job? No, we're just doing something else. So I think that, like a lot of these things, yes, there is a shifting of job types, but it's been proven time and time again that the cloud is generating more jobs than it's actually displacing overall at the end of the day. And it is having the ability to have the cloud there to share and to spread knowledge is the singular most important thing to be able to move mankind forward.
Yeah.
You look at the show Starter that comes out every time, where we talk about C# Corner and how it started out as a seed and then it grew and everything else. And I said to my partner Una the other day, I said, would you believe it? C# Corner is actually, it's in the top sort of, 2,500 of websites on the internet. And she went, is that all? I said, can you imagine how incredible that is? Can you imagine how incredible that is to be in the top 2,500 sites of the internet? Like, it's unheard of, right? Like, for something that started off just as a side project by Mahesh in his bedroom to turn into this, we're impacting so many lives on a daily basis. I was looking at some of my stats the other day, because you get a little bit obsessed by statistics when you start sharing the community, right? And even though I haven't written a physical article, I used to be quite prolific in writing articles, but at the moment, because of my startup that I'm in, all of my time is consumed with that, right? But I would shove out articles and shove out one or two a week and write, and it was really cool because people would see those. And even though I haven't written a new article in about 6 or 7 months, I went and had a look at my stats on C# Corner the other day. And despite the fact that I haven't written a new article, right, in over 6 months, I have gained another 500,000 views on my existing articles, right?
That's great.
And that's 500,000 people who have gone to C# Corner who are still getting benefit from stuff that I've written 6 months ago, 6 years ago, 16 years ago, right? And that's so awesome that knowledge is shared. And this is the thing about the cloud. The cloud is about being able to share knowledge and share information. And it's the only way that humanity will continue to push forward and to make sure that we do it for good, of course, So next question, go.
That's beautifully answered, Alan. Definitely, not just on C#, or I think some people have invested a lot of time on their YouTube, right? They just go in and upload one video, and if it's monetized, voila, that video is gonna give you money all time, right? So even that's, people have done it nicely. And quick update that C# now runs entirely on Azure. We were down last month for a couple of days. I don't know, it was all over the internet, but we are now running entirely on Azure. So yeah, you have to keep yourself updated. We were first on-site, then we started using some other services. Then we went on multi-cloud. Then we realized that, okay, let's just go ahead and stick to Azure because that's working best for. So I know we are a little over time, Alan, right? And your time is very sensitive. So I'll just ask you one last question, maybe like second last question. That what does this actually mean? How does a digital twins fit into the cloud? What the heck is this?
Digital twins. Okay.
Let me just go ahead and put it on screen so that everyone can see it. So even there you can see, everyone's like, what is that?
Digital twins. Okay. So you think like it's going to be like these cyborgs, these robots going around,
Yeah.
twin A and twin B, robot A and robot B. A digital twin is a representation of something that is in the physical world,
Hmm.
but it is replicated in the digital world. Now, practically, I'm going to give you a real practical example. Let's say I have a building, and it's my office building. In fact, let's say it's not an office building, right? Here's an interesting one. Let's say, in fact, okay, no, it is an office building, right? I have an office building, and it has maybe 5 or 6 floors. Okay, so it's actually not unlike the C# corner office in Delhi, right? And I know that office well, and how we walk up the outside steps, and then we have the different floors and the different sections in the rooms and everything else. And we have one area that we can teach people, another area for
Oh, you remember
operations, and we
everything.
have
A
a
lot of
meeting
things.
room, and yeah. And I
You have
really like the
understanding.
table that we have that has all those pebbles in it. We sit around and we have some nice coffee and chai.
Yeah, it's
Yeah,
still there.
yeah. So we have all these areas, right? And maybe we want to know how is the health of this building, right? Because now everybody's working from home, and there's only somebody going into the office maybe once a week just to check for post or whatever. But what happens if something goes wrong when you're not there? Right? Let's say there's a flood, right? So we got some monsoon, and there's a hole in the corner of a window that somebody forgot to close, and water starts coming in, and then the hinge gets rusty and it breaks open. So the window now completely falls open, and that's beside maybe the server room, because you still have a server room,
Oh my God.
and maybe the water starts coming in, and suddenly you're in trouble, right? So the first thing we have IoT sensors, right? So we've got sensors around the building, and those sensors collect data, and the data is sent up, and we have some monitoring system that says, make sure that you check for a leak or whatever it happens to be, and to fix that thing. And the second thing then that we have is we have a representation of that. And the representation of the building is not one that necessarily takes in the live data, but one that says, I'm a bit like a CAD drawing of this building. And you can look at the building like in, this, what's it called? Augmented reality, so you can do this walk around of the building in 3D, and you can see where all of the sensors are, and you can pose a question to the system. So you can say, what would happen if that particular window over there started breaking and let in water? And you could run a query on it, right? And it would show, oh, well, if that area there filled up, the pressure on that particular part of the floor would cause the floor to cave in, which is, because it's on floor 3, it's actually the ceiling of the floor of floor 2. So that would cause a sensor underneath there to realize that something was after breaking. And then the next thing, da, 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 da. So a digital twin is a representation of something that's in the real world, in the digital world, and it allows you to model things that might happen and model things in advance. You might be able to say, for example, if the external heat went to a certain degree, to a certain temperature outside the building, what is the efficiency of the air conditioners inside to allow us to keep that building cool?
Yeah.
So you might find out that actually, if the external went up by an extra half a degree, that actually your air conditioners are not efficient enough, right? You could then use a digital twin, and we have digital twins for cities, right? And this one is really, really cool. And I'm involved in a project at the moment. They're building a brand new city in Morocco. and we're getting involved in this project. And for example, let's say you've got all of these streets, okay, and you have all of the traffic lights on all of the street corners, and you have pedestrian zones, and you want to know what's the flow of the traffic. So we have the sensors on the traffic lights. We have sensors in the ground underneath the traffic light, so that you can see how long has a car been sitting there waiting, and then you can change the traffic lights depending on this. It's okay. It's in this physical world. It happens all the time. So let's take that as a model and put it inside in our digital twin, our model of the physical world, and say, what else can we put on top of that now? Okay, so why don't we put in the weather, right? So let's overlay the weather into this. So we now are putting digital weather into our digital world, right?
Yeah.
And we can track that the weather is a particular type, and we can say, well, there's actually monsoons on at the moment. It is very, very wet, and we know that cars tend to go slightly slower when it's wet, because people are more afraid and more nervous. But we also know that there's more accidents with people back-ending into cars, right, when it's wet. So we can then run some machine learning experiments on the digital twin to say, if we adjusted the timing of the traffic lights for the traffic flow, taking into account the weather, the traction, people's reactions in their cars, could we actually lower the amount of accidents on the road? Okay. Could we do it by maybe allowing one traffic light up that area to go to green even 5 seconds before the one on this area? Will that create enough of a movement that will reduce the amount of accidents? We can do that. Then we can go one step further and we can say, actually, just around the corner, there is a market, and around that corner, half a kilometer away, there's also a stadium where there's going to be some concert on, right? So could we actually go out and could we put up some monitors, and could we look at the amount of Wi-Fi, right? Like if I go and I put up even 3 Wi-Fi hubs, right, in within a few 100-meter radius, I can count the number of unique phones in the area without them ever knowing I'm doing it, right, by triangulation, because they will automatically try and seek out a network, right? So I can use that to help me understand in real time if there's a surge of people coming into a particular area. I can know that the likelihood of more people on the streets with more cars means that there's probably going to be more accidents. Therefore, I should slow down the traffic lights, or I should speed up the cars, or whatever it happens to be. So the key of digital twins is that it allows us to have this representation in a digital world of what's happening physically, and to run experiments to make sure that we optimize the physical world. Now, I know we're going to have a show about that at a later stage. But even before that, it's an absolutely fascinating area. I've got an analogy that I won't talk about now, but I will just suffice to let you know, we're going to talk about vacuum cleaners.
Why is that?
I'm not going to tell you. You're going to have to tune in to the next show that I have about digital twins, and I will tell you all about vacuum cleaners and digital twins. Okay.
Wow, that
And
sounds
what the connection
interesting.
is between. And I'll also tell you about frogs, vacuum cleaners, digital twins, and the cloud, coming to a show near you next time. Tune in, same channel, same time.
I mean, so I think that was really nice. So, if it makes sense, so can we say that IoT plays a big role in this digital twin? Can we say that?
Absolutely,
Yeah.
absolutely. IoT has a huge role in digital twins, and sensors have a huge role in digital twins. Digital twin is something that is really starting now to take traction and to grow. And what we're going to see sooner rather than later is we will see the digital twin concept becoming as ubiquitous as the mobile phone. So when
Mhm.
people talk about the mobile phone now, like I remember, she'll kill me now, but my better half many years ago, when we showed her the first iPhone, she said, "Why would anybody need the internet on their phone? Why would anybody need the internet on their phone?" Right? And I
Mhm.
guarantee you, within probably 5 to 7 years,
Mhm.
everybody will assume that we have smart buildings. Everybody will assume that we have smart items. We'll assume that when we pick up our headphone, it will automatically connect with something. We'll be able to see where it is. We'll be able to say, "Where's my headphone?" And I just pick up my phone and say, "It's 200 meters that way." Right?
Yeah.
Where's my car? What's the efficiency of my car this week? Everything will be connected in with a digital twin, right? We will have sensors. We have our Fitbits, which have been taken over by Google, which will be part of the digital twin, the human digital twin. We have our glasses that we wear, that will be able to have our. We've already seen them with the
Yeah.
micro cameras bringing everything in for augmented reality. We have the incredible technology that we see in with mixed reality with the Microsoft HoloLens. And this is very much fitted in with digital twins, especially when you look at industry. You talk about factories, you talk about technicians, you talk about plumbers, electricians, um, uh, even down to a dentist who's in, doing something in your mouth and they need some assistance. Well, what can they do? What about if they had a hollow lens on and they're looking in and they're able to send a digital representation live over the internet to some specialist who's able to say, "Don't touch that tooth, it's gonna pop."
If that happens, I'm not going to that dentist, to be honest. If my dentist is putting on a HoloLens.
Yeah, then it's time to run. Or maybe that's the dentist you want to stay with. Because if you go down next door, you're going to go into the AWS robotics lab and they'll have
Oh
a
my
robot hand coming into your mouth. Rah! So who do
God.
you want? Microsoft HoloLens, or Bezos in your beak? Bezos in your beak. Bezos in your beak. Yeah.
Let's just stay at home for now. Let's do 2 times a brush a day, and so, guys, we're already at time. This show was only for 30 minutes, but I think we have done 2 episodes on the one day. What an amazing show, Alan. And towards the end, when you bring the topic of digital twin, that definitely tells that that is the big future that we're not looking, not just for the cloud computing, but I think digital twins covers the entire ecosystem of cloud computing, data science, machine learning, IoT, and a lot of stuff. Pretty exciting thing to talk about today, starting from what is cloud, what are the challenges, what we have achieved so far, what can be done, and what's the future. So, Alan, that was a great show. Thank you so much for tuning in. Any last words before we go ahead and close the show?
No, again, as always, to me, the most important thing is to spread the word, to say to people, share your knowledge, tell everybody
Mhm.
what you do, help others. It's the only way we can move forward, especially now that we have this very, very strange time on us. It falls down on us even more to help everyone around us. It doesn't matter whether it's in computers. If there's an old person living nearby, go and help them. Bring their groceries out. Bring their dog for a walk. Go and chat to them, talk to them. Right? People are lonely, so reach
Yeah.
out and communicate. Keep communicating. That's the message. Keep communicating.
Yeah, exactly. Keep communicating, keep doing the live shows. We will keep on doing live shows every other day because definitely this cloud has given job to me too. So that's also important. So thank you so much, everyone who has joined us today. See you in the next episode, and definitely see you on the SQL conference scheduled on Friday, where we raise fund for kids affected by COVID-19. And as always, stay connected and empower every other guy. So thank you so much,
Take
and
care.
see
Bye bye.
you. Bye bye.